Now permutations when some of them are alike. This is how we describe it. The number of permutation of n things taken all at a time when p of them are alike and of first type, and q of them are alike of the second type, and r of them are alike of the third type. The remaining are different, is equal to n factorial divided by p factorial into q factorial into r factorial in the denominator. The reason can be explained as under. Consider any permutations, that is arrangement, in this case where p are alike of first kind. This permutation remains unaltered if we permute these p alike things. They are all alike, which gives up p factorial ways. Similarly, if we permute q alike things of second kind in their own places, the permutations will remain unchanged, which give us q factorial ways. Clearly, third kind of r alike things give rise to r factorial ways. Thus, the number of different permutations will be n factorial divided by p factorial into q factorial into r factorial. Next we take up the permutations where repetition is allowed. The number of permutations of n different things taken r at a time when a repetition is allowed is n raised to power r. It can be easily conceived, since the repetition is allowed, for every place we have n objects at our disposal. Thus, n options mean r places, and for every place there are n choices. Hence, the number of ways of filling up r places is n into n into n up to r times, which gives us n raised to power r. Next we take up circular permutations. They are also called cyclic permutations. Any arrangement round a circle is called circular or cyclic permutation. It has no head or no tail. Just as ABCDE, BCDEA, CDEAB, DEABC, EABCD are, when placed around a circle in this order, they represent the same permutation, that is, an identical circular permutation. Clearly, if there are 5 objects to be arrayed around a circle, every 5 linear permutations are identical in a circular permutation. Therefore, the number of circular permutations of 5 things will be 1 upon 5 times 5 factorial, which is equal to 4 factorial. In general, number of circular permutations of n things are 1 upon n into n factorial, which is equal to n minus 1 factorial. If no distinction is made between a clockwise or an anti-clockwise permutation, the number of such permutations are further reduced to half. Number of such permutations therefore becomes 1 upon 2 times n minus 1 factorial. If there are n different persons sitting around a table for dinner, the number of arrangements will be n minus 1 factorial. But the number of arrangements of n different beads, the number of such different necklaces that can be formed is 1/2 of n minus 1 factorial. Because while forming a necklace of beads, the clockwise arrangement and anti-clockwise arrangements have no difference.